Hello and welcome back to Compiler Programming. Today I thought I would work a bit on improving our jump and branch code. So if we look into the function where we are using it, which is, I believe, make is non-zero. So this code still does not look much like an if statement you might be used to. So let's try to make it a bit better. And we are gonna start with figuring out how can we turn it into something resembling a statement. So in C, usually if you want to make something that has a precondition or like piece of code that goes before and piece of code that goes after, usually the way you do that is with a for loop, and this is, for example, how these each statements are implemented as well in the test framework. So knowing this pattern for macros is really handy if you're writing C. And I guess this is the same thing we can do here. We can just say that so the idea would be that we have something that that gets us a patch in, so something goes here as a first thing in the for loop. Then it is always false. So we just want it to go once because we're not using it for the loop. We are just using it to kind of have this way to execute something before and after. And after is this thing, right? Is page jump to here and builder page. So we have something like this. Then inside of it, we can put the body of the statement, right? Now, one annoyance for us will be this return page. So let's just bring it up a bit for now and then figure out how we want to deal with it a bit later. And put it here, right? Now we also want to somehow combine these two things, right? Because essentially it would be nice if we passed just an integer value to some kind of function, and this is what the if statement would use. Because if you think, like, in case you don't know, a Boolean value that you have inside a comparison is just an integer, and maybe later on we'll introduce a specific Boolean value, but this is definitely not a priority right now, so simple integer will do. I guess we could have something like, what might it look like? Page 32 make if, I guess. And it accepts something and returns to us this thing. So obviously we now know that it needs to accept a builder. Okay. And it also will need to accept some kind of value. So let's say, if we want it to be nice to deal with, I guess it should actually accept value by value rather than by pointer. Don't know. Let's try it this way. And it again, it's gonna be rather inefficient, but what we're gonna do is we are gonna compare the value with 0 here, I guess. Now that I'm thinking about it, the issue that we are having is this compare, it doesn't actually kind of return any value. It only affects the flags register in the CPU. So that means that if we, to make this work here, we either have to extract the value from the flags to some kind of value that we can actually use and compare with, or we'll have to pass the kind of the comparison operation to the if itself. And I'm not sure which option is better for now. Well, let's start with something simple. Let's just first migrate this current code and then go further from there. Maybe for now we'll actually just keep this as it was, in a sense that we will do the comparison before the if itself and introduce a special value a bit later. For now, let's just see that this works. So patch will now be make if, right? Make if of builder. And then we can remove this one. And we can put this stuff here. Okay. Let's see if this works. I will remove this value for now from here. Okay, so this builds. Let's see if this actually works. Okay, and I did screw up something along the way. Let me have a quick look of what is the problem. So we do the compare, we get the patch. Oh, yeah, so the thing is we do want the loop to run once, and if the condition is always false, then it never actually runs, right? So here, I guess the way we can deal with this. So the unfortunate part about for loop and why this is gonna become a bit messy, I guess, is that this part kind of, we can only initialize either one variable or multiple variables, but they all need to have the same type. And it's a bit messy to deal with this, but the one way you could sort of work around it is say that we're gonna have star applied, and make patch jump to here actually return something, which is a bit messy, but it should work for now. Let's do the simple version where we just say S32 S32 index is 0, and here we say condition of the loop will be while not index plus plus. So that should work. Okay, that's work. Now obviously we probably want to get rid of this variable in here and do something different instead. Like one of the tricks is we can do star dummy, whatever you want to call this thing, and it's gonna be 0, and we can do, I think, the same thing to it. Okay, that does compile, but let's see if that works. And it does work. So this is a bit weird, but what we are doing here is we are like, some people actually think that when you do multiple variables that the star belongs to the type, but star actually is part of the variable declaration. So here we're defining a new variable that is a pointer to this type, and in reality it doesn't even matter what this type is, because it can be also a pointer or whatever. And we initializing it to 0, then we are moving it by the amount of the size of patch 32 in this case. So it stops being 0 and the condition fails at the end of the loop. So this is just this weird quirk of how you can make this kind of loops work. And once we have that, we can also start thinking how we can sort of work around this and have a macro that does this for us, right? So we extract this stuff and see what we need to pass to this. If we always expect our thing to be called builder, which might be okay for now, then we also can create some weird looking variables just to make sure that they don't clash with any variables that we use. So dummy, and I guess we will have a problem with nested ifs if we do something like this. So this is something we'll need to think about, but for now that's fine. Okay, so let's replace our for with an if, and eventually this is what I wanted to roughly look like. Let's see that it still works, and it does, which is good. Now the tricky part is, as I mentioned, we need to somehow put this stuff into here for it to be nice to look at and look as the code looks like, and not some weird encoding thing. How do we want to do it? I guess so. One way to deal with this would be, for example, to go here and add a new descriptor type that is, I don't know how we want to call it, flags, I guess. And that means that this value is persisted only in the flags of the CPU. Just to make sure that we are on the same page of what I'm talking about, let me start dev environment with and show you. So let's go to our function that we are working on right now. And this is this one. And if I go into here, then I go into disassembly, and I jump in the call. This is the code that we are looking at. And the way that it works is, if we look into registers here, you see these flags. Once we do compare, these flags will change, and then this instruction uses values of these flags. Then, as you can see, like some instructions actually change the values here. They're marked red. And now we have compare, and ZR is probably 0, OV is overflow, I guess. There is a description of all of these flags in the Intel manual, so you can look it up there. If we now go further, these flags did not actually change, but jump instruction used their values to do the right thing. Now, one problem is that these flags basically change based on a lot of instructions. Like all arithmetic instructions and some, I believe some non-arithmetic instructions might change these flags. So that means that that value would only be valid right after it was created. And I'm not entirely sure if this is the right way to approach this. But I guess this is one way we could do it. Another way is for us to figure out how to, I guess it's a safer option, is to move from flags register or something like this. Like there is a command that allows you to kind of take one of those values that we saw and put them somewhere else. Okay, this is not what I want. Could be like move cc or something. No, move cc is a conditional move. Yes, this is the instruction that I was looking for. It's called setcc. Yeah, set byte on condition. Basically, the idea is that now we can accept, we will, whenever we do a comparison, instead of just keeping the value in those flag registers and using right away in if, we would kind of do a two-step version where we first, I mean, it's going to be redundant stuff, obviously, and unoptimized, but this is something we can figure out later. What we will do first is this. Let me close this down for now and go back to here, and let's try to change this code to to be what I mean. Okay. What we are trying to encode here is the code that does this. We have some kind of a value and we're saying like arg0 is equal to 0, right? This is this comparison. Now we can, or actually like not equal to 0. This is how we're doing. Like if it's not equal to 0, then we, let me think about it. No, we are actually doing this. We are comparing to 0. So we can go into here and I guess we can search for 0. So this is not 0, but I want to have if 0. So we can do this instruction, set byte if 0 to something. Let's try to add this instruction first. Like we will not change anything in the current code, but we will also try to save the result of our comparison into a different register. And as always, we will use arrayx register as our guinea pig. Now, one thing to note here is this instruction sets a byte. And because it sets a byte, that means that if you had anything else in your register, that will not be overwritten because register contains 8 bytes. And even if you target like 32-bit register, you still have like 3 extra bytes that will not be overwritten. So we need to manually do it. So we can actually start with that. And again, this is going to be inefficient version of this. And inefficient version of this looks like this. We take our AX register and we move 0 into it. So we clear out whatever else. And the thing is, at least I believe, if you move, we can actually move to arrayx to clear it and not have to deal with whether it will be overridden if we use 32-bit version. But I believe it will. Okay, we clear out the target register and now we can use set, I guess it's called setz function or instruction to move the result of our comparison into that register. So we say setz and the only operand is arrayx. In reality, we don't really need it to be arrayx, but it also doesn't matter. We can use any version of the register here because it's just going to be lower byte anyway, but for simplicity, we can keep it arrayx, even though, again, it's going to generate too much bytes in the code. Okay, obviously this doesn't work because we do not have the encoding for it. Wrong file. I meant this one. And here we have this J and Z. Let's add another thing, which is going to be setz, right? So we have setz. It only has one version, that is register memory, and it has this 2-byte instruction type, and there is, I guess there is no extension. Yeah, it's also going to be interesting if our encoder actually deals with this stuff correctly, because I don't remember how it decides if modrem is necessary, if it looks at extension type, but let's see. Okay, so we have setz. Let's try to build this. It does build. Now we want to try again to see what is going on with the resulting code. Let's start the debugger. It doesn't have the file. Let's run the tests. Tests obviously still pass because we are not actually doing anything in those instructions, although maybe the instructions were broken, so at least that's a good indicator for us to see that this is not completely wrong. And I pressed the wrong button. We need to go here, here, here. Okay. So we have this clearing and set AL. And if we go through these instructions, now we can inspect arrayx register, and arrayx register is 1. So now we have that Boolean value that we wanted, right? So we have a value that says is argument 0. And it's also sort of in the right, not inverse like it was before, because here we are doing jump NZ, and we are still going to be inversing for the jump, but at least it's easier to understand on the side of the user. Okay, and you can see this comment of use XOR that I added. Like, this is just a better way usually to clear a register. Basically, if you do a XOR operation between the register and itself, then it clears it. Because XOR results in 0 if both things are either 0 or 1, and if you're doing it with itself, then it's always going to be one of those. But one of the downsides of XOR actually is that we would have to do the clearing before the compare, because XOR is one of those operations that actually messes up with the flags register. Okay, so now we have this value, and it is inside of arrayx register. Let's actually turn it into a value. Value can Boolean or conditional, and what that value is going to be, it is going to be, as I said, type of it is actually not type, descriptor is, yeah, that one, descriptor integer, and the operand is arrayx. Now we can change this to be like so. Oops, dot in the wrong place. Now it probably, what does it complain about? Arrayx is not a member of value. Yeah, it shouldn't be, it should be operand, not arrayx, obviously. Okay. So we have a value for the result of our comparison, which is nice. And now we will pass this value to the if. So we need to accept a value here. Value. And we will actually need to do another comparison with 0. Maybe there is a better way to do it. But now we say that, so we got a Boolean value. So in other words, a value that is either 0 or anything else. And if the value is 0, that means that condition is false. And we need to skip over the block that is the body of the if statement. So we actually now have to change this to be like jump if 0, not jump if not 0. So we also need to add this new instruction to our encoding. Here we go. We have jump not 0. Now we need to do jump 0. So we go to JCC. Probably it's at the very end. Jump near if 0. It is 0f. I will remove this version because I'm not interested in it. And we say 84, right? And now we need to change, obviously, all of this stuff to match the right thing. Too many arguments to function like macro. Yeah, that is very true. Okay. Now we say we compare value operand with 0 and make a jump if 0. That seems reasonable. Okay. Now we need to propagate it here. And like so. Something still wrong. Buffer should be star. Okay. That seems fine. Looks good. Oops. Let's see what our debugger says about our code now. Oh, of course, it doesn't say anything because it doesn't. Okay, it still works. Let's check what it looks like. And that's gonna be hopefully what we want. And you can see this XOR here, like what I was talking about. Like if you want to get 0, this is the preferred way to do it in x86 assembly at least. Okay. So code is exactly as we laid it out. We do the first comparison with 0. We start in a register. Then we compare that register with 0 for our jump. And if the like JE and JZ actually share the same instructions, same mnemonic, because sometimes you want to say equal, sometimes you want to say is 0, and in reality it's the same thing for the CPU. But in the assembly you want to express intent rather than necessarily the exact thing that the CPU does. Yeah, and we can see, we can go through here, we compare with ArrayX, and again we can look at the flags. We see that Zero flag is 0 because rex is 1. So we don't jump. Instead, we go into here and do what we needed to do, which is great. So now we have this if that looks much closer to what we expected. Now we can actually turn this into another helper function, so it looks even more close to what we wanted. Nice. I'm not sure if I already have something that I can update. Divide, multiply, assign. Guess not. So let's create a helper function that will be, what will it be? It will be, it obviously needs to return a value, and it will be equals. And also it's very easy to guess what it will accept. It obviously needs a builder, it needs value A, and it needs value B. Same as in other stuff, to do type checking. Okay, and now we take this stuff and move it here. Now another thing is, yeah, I guess this is fine. So we are, now I'm just thinking what should go into this condition, because the function should read like this, like if equals, so let's try to write usage code first, and that will help with the figuring out what should be the right thing. If builder, and I actually need to get the function argument. This is how I do it. Right, so this is going to be another improvement to this function. We say we take the zeros argument, then we say if zeros argument is the same as value from S64 0, then we return 0. Otherwise, we return 1. Okay. So obviously this goes into here, a dot operand, b dot operand. That's good. Let's see if this, yeah, and setz I think is also the same as set e, because it's the same as jumps, right? So if I do set e, set e, yeah, it's the same code, so it actually is the same. Maybe I should add an alias for setz to be also set e. I can have the buffer issue, but that one is easy to fix. we still need this. Okay, let's. Okay, still doesn't work. Initial laser is not constant. Yeah, it's this thing. So I guess I need to keep it like this. Okay, good. Let's check it out. Did not find an acceptable encoding. Okay, that's not good. But I guess now the issue is that comparison failed. Yeah. Yeah, we have this issue with immediate value stuff. So that's why it should be like this, I guess. Okay, great. It works. One final touch I want to do before wrapping this up is the same thing as we discussed in the arithmetic operations. So we are right now straight up returning array X register, and this is not nice because it like we can override it in next operations with something else. So we should put it in a temporary value and return that instead. Where do we do this? This is how we create a temporary value, and we can put it in our equals temp and return temp, or let's call it result. Okay, and reserve stack, conditional descriptor, and then we are moving from conditional. I actually don't need this value now. If we are using array X directly, then this is fine. So we put it here and here, and then we actually directly say descriptor integer, and like so. I guess I messed up something. Dot operand must have struct union. Yes, it's called like this. Okay. Let's check it out. It still might explode because I'm not sure if we accept memory there, but apparently it does not. Everything works great. And now we have this very nice kind of domain-specific language or embedded domain-specific language where we can start writing code that actually resembles the right thing. I can also even create a quick something like this, and A and B, right? And just take out these equals, put it here, and put it, sorry, like so. Actually, it needs like this. Now it will look even closer to the nice thing, right? This is pretty readable now. Obviously, you cannot, as I said, you cannot have nice operators in C because you cannot do operator overloading unless you go to C++, which I don't want to do for now. But if we we can read this pretty nicely. Let's recheck that this works. Indeed it does. And we created an if statement which looks and behaves very similar to one in C, which is going to be a big help, I think. I think that's all for today. Thank you very much for watching and see you next time.